Night settles over the Giza plateau. The desert cools, the air grows still, and the Great Pyramid looms like a frozen wave of stone. Too vast, too precise, too silent to seem man-made. Beneath its shadow, a question older than civilization itself stirs. Who truly built this? For centuries, we've been told a story that fits neatly into textbooks, tour guides, and museum plaques. But the more closely we look, the more that story begins to crack. The accepted tale begins around 2580 BC during Egypt's 4th dynasty. King Khufu, or Cheops as Herodotus later called him, supposedly ordered his royal architects to construct a tomb that would secure his passage into the afterlife. The logistics alone sound superhuman. More than 2.3 million blocks, each averaging 2.5 tons stacked with near machine precision to a height of 146 meters. Egyptologists estimate that tens of thousands of laborers quarried limestone from Tura, fide granite from Aswan nearly 800 kilometers away, and assembled this mountain in just 2 decades. It's a remarkable claim. What do you make of this symbol? Yet when you trace its origins, you find that most of it rests not on ancient records, but on modern interpretation. The first written description comes from the Greek historian Herodotus, who visited Egypt around 450 BC, roughly 2,000 years after Khufu's supposed reign. Herodotus never saw the construction. He merely repeated what priests told him. They spoke of ramps, of stone quarries, of 20-year labor projects. But his accounts also mention winged machines and sacred magic that raised the stones. Details modern historians quietly omit. In fairness, Herodotus wasn't a liar. He was a collector of stories, part historian, part mythographer. Still, every modern classroom lesson about the pyramid begins with his second-hand words. Then comes the 19th century, an age of imperial archaeology. Among the explorers who descended on Egypt was a retired British colonel named Howard Vyse. Obsessed with making a discovery that would secure his reputation, Vyse brought to Giza not patience or precision, but gunpowder. In 1837, after weeks of blasting through sealed stone with dynamite, to the horror of his Egyptian workers, he found a small chamber above what is now called the King's Chamber. On the granite beams inside, his men reported seeing red painted marks, hieroglyphic symbols, and royal cartes. One cart contained the name Khuf. It was the missing puzzle piece everyone had been waiting for. Vyse announced that he had found the builder's signature, direct evidence that Khufu commissioned the Great Pyramid. Overnight, his name entered the annals of Egyptology. The discovery was hailed as final proof that this was indeed Khufu's tomb. The textbooks were rewritten. The case, as they said, was closed. But science, when done properly, never closes its case. Years later, other Egyptologists noticed peculiar details. The red marks were painted, not carved, unlike the inscribed, carefully chiseled hieroglyphs found in royal tombs. Some of the symbols were misspelled, errors no trained scribe would make, but identical to hieroglyphic examples printed in a 19th century British reference book, Vyse owned. The pigment looked unnaturally bright, lacking the micro-cracking and fading expected of 4,000-year-old paint. Modern pigment analysis revealed that the red ochre sits on top of quarry marks, meaning the paint was applied after the blocks were placed. If those markings were genuine, they should have been buried beneath the dust of millennia, not gleaming above it. Still, Vyse's proof was too convenient to question. His claim resolved centuries of uncertainty and gave Egyptology the solid anchor it craved. From that moment, everything else, the dating, the engineering, the cultural meaning was built atop that fragile foundation. When archaeologists later searched for corroborating evidence, they found nothing. No papyrus scrolls from Khufu's reign describe the construction. No wall paintings show the workers or tools used. Even Khufu's own statue discovered at Abydos is tiny, barely 10 centimeters tall, the smallest representation of any major pharaoh. For the builder of humanity's largest stone monument, the archaeological silence is deafening. Yet the story persisted, growing stronger each time it was repeated. Scholars pointed to the nearby worker village discovered in the 1990s, the so-called Pyramid City. They argued it proved a large state-sponsored workforce lived at Giza, and it does. But the site also shows signs of long-term occupation, not a single 20-year project. Pottery, animal bones, and charcoal radiocarbon dated from that area spans several centuries. The evidence tells of maintenance, restoration, and ritual activity, not necessarily original construction. Even Herodotus' chronology doesn't align cleanly with geological data. Erosion patterns along the pyramid's base and the nearby Sphinx enclosure suggest exposure to heavy rainfall. Rainfall that ended thousands of years before Khufu's time during the wetter climate of the early Holy Sign. This observation, first made by geologist Robert Schoch in the 1990s, ignited fierce debate. If correct, it would mean the monuments predate Egypt's desert phase entirely, belonging to a forgotten era when the Sahara was green. Of course, the orthodox camp rejects that conclusion, pointing instead to wind erosion, but the crosscut channels carved into the limestone run vertically, not horizontally, consistent with water runoff, not sand blasting. Nature, it seems, carved its own timestamp into the stone, one we prefer not to read. Still, skepticism of the official story isn't new. From the Renaissance onward, travelers describe the pyramid not as a tomb, but as a mystery. The 17th century astronomer John Greaves measured its dimensions and noted geometric ratios beyond practical architecture. In the 20th century, engineers like Flinders Petrie found the base level so accurate that it deviated by less than 2 centimeters across its entire perimeter. The deeper researchers looked, the less the story of copper chisels and slave labor made sense. Yet, the narrative held because it is simpler to believe in genius than to confront amnesia. What keeps that story alive isn't evidence, but repetition. Centuries of scholars, guides, and institutions reinforcing the same convenient truth. To question it feels almost heretical, a challenge to the pride of human progress. But the stones themselves are indifferent to pride. They tell a quieter, older story, one we've barely begun to translate. And that story begins not with a pharaoh, but with an absence, the missing proof of his hand in its making. To understand what might fill that void, we have to return to the source, to the red-painted symbols that began this legend, and to the man whose ambition may have forged the cornerstone of a global misconception. In the next part, we reopen the chamber Colonel Weiss claimed to discover, to examine the evidence, not as history decrees, but as science now reveals. Morning light creeps across the desert, sliding down the pyramid's smooth flanks until it glints against the very stones that changed history. Or perhaps deceived it. For if the story of Khufu as the builder of the Great Pyramid rests on a single discovery, it is the one made by Colonel Howard Weiss in the year 1837. A set of red-painted hieroglyphs hidden high within the pyramid's interior. The evidence that transformed speculation into certainty, the proof that made Egyptology comfortable. But when we step back into the chamber where those marks were found, and we look with the eyes of both a scientist and a storyteller, the tale of their discovery begins to feel less like revelation and more like confession. The man behind that confession, Colonel Richard William Howard Weiss, was not a trained archaeologist. He was an ambitious British officer with an interest in ancient mysteries and a fortune slowly slipping away. Egypt in the 1830s was the Silicon Valley of glory seekers, the place where fame was mined from sand and stone. Men like Giovanni Belzone, an Italian strongman turned tomb raider, had become legends by unearthing statues, mummies, and treasures for the British Museum. Weiss wanted the same immortality. But when he arrived at Giza, he found himself overshadowed. A young rival, the skilled explorer Giovanni Caviglia, had already begun exploring the Great Pyramid's inner chambers and gained the support of local officials. Frustrated, Weiss used his wealth to outspend and outmuscle his competitor, hiring more workers, bribing guards, and ultimately locking Caviglia out of the site entirely. He took control of the pyramid the way generals seize fortresses. Then he began blasting. In his own journal, Operations Carried On at the Pyramids of Giza, 1840, Weiss describes how he used gunpowder to open sealed passages and chambers. The explosions cracked ancient granite, scattering dust and smoke through corridors that had been silent for millennia. To later Egyptologists, this approach bordered on vandalism. To Weiss, it was determination. But after months of destruction, he still had nothing to show. No inscriptions, no treasures, no discovery worthy of fame. His funds ran low, and his reputation among fellow explorers was crumbling. Then in late March of 1837 his luck changed, or appeared to. While tunneling upward from the so-called King's Chamber, Weiss's team breached a series of narrow spaces later named the relieving chambers. Small cavities designed to distribute the pyramid's weight. On the beams of the highest of these, the one now called Campbell's Chamber, his men reported faint red painted markings. They were roughly drawn, scattered across the granite-like graffiti. Among them was a Kartu, the oval name ring of a pharaoh, reading Khanum Khufu. Weiss announced the discovery with triumph. To him, this was the missing link. The builder's signature carved, or rather painted, into the heart of the monument. Newspapers across Europe celebrated his find. Egyptologists finally had their proof. The Great Pyramid was Khufu's, the Fourth Dynasty's crowning achievement. But from the beginning, something about the marks didn't fit. Unlike the carved hieroglyphs found in royal tombs, these were crudely painted, uneven, almost rushed. Some overlapped construction guidelines, quarry marks used to align the blocks, suggesting they were added after the stones had been placed. Others contained spelling errors. The hieroglyph for Khufu was drawn using the wrong symbol, a sign that wouldn't have existed in his era. Incredibly, that same mistake appears in a hieroglyphic reference book published in London just years earlier, a volume that Weiss owned and cited in his notes. Modern researchers like Zechariah Sitchin and Scott Croton have studied photographs and tracings of the marks. They point out irregularities invisible to the casual eye. Brush strokes inconsistent with ancient paint, pigment that lies above dust layers rather than beneath them, and strokes that end abruptly as if drawn from awkward angles by someone standing on scaffolding. Some marks run beneath later chisel lines from when Weiss's team extracted samples, a clear indication they were freshly applied. Chemical analysis in the late 20th century found another clue. The red ochre pigment shows no crystallization or mineral breakdown processes that typically affect ancient paint after thousands of years. Under magnification, it looks disturbingly modern. And then there's the most suspicious detail of all, the absence of any mention of the marks by Weiss's assistants in their original field notes. The first clear reference to the Kartu appears only in Weiss's later journal entries written after he had dismissed or fallen out with several of his foremen, including the ones who first entered the chamber. A pattern begins to emerge, one not of discovery, but of desperation. Imagine Weiss that night, broke, mocked, overshadowed, and out of time. One stroke of fortune could transform him from a failure into a legend. All he needed was a pharaoh's name. A few painted hieroglyphs copied from a book applied in the dark with red pigment and camel hair, and the course of Egyptology would be changed forever. Was it forgery? We cannot say with legal certainty, but even cautious historians admit the inconsistencies are troubling. The scholar Richard William Howard Weiss Jr., the colonel's own descendant, wrote that his ancestors' accounts were laced with contradictions. Egyptologists rarely discuss this publicly. The foundation of an entire chronology depends on those red marks being genuine, because if they are not, if the name Khufu in the pyramid is a Victorian fabrication, then the monument becomes undated. It could belong to the Bronze Age or the Ice Age. And that opens a door no one in orthodox archaeology wants to walk through. In 2011, advanced digital photogrammetry allowed researchers to re-examine high-resolution images of the chamber. Under filtered light, the red marks show modern layering. Brush fibers embedded in the pigment, a technique unknown to ancient Egyptian artisans who used reed pens or finger application. When scientists compared the mineral composition of the ochre with that of known Old Kingdom pigments, they found subtle chemical differences, traces of industrial iron oxide consistent with 19th century paint sources. Still, official institutions refused to permit further sampling. The Great Pyramid, they said, must be preserved. But sometimes preservation can mean protection of a narrative rather than protection of stone. The irony is striking. The entire chronology of ancient Egypt, its dynasties, its pharaohs, its cultural sequence leans on a few centimeters of red pigment discovered by a man using dynamite in a rush for fame. If those marks are younger than the pyramid itself, Every date that depends on them begins to drift backward into an era we do not remember. And so the name in red paint meant to close the case becomes the beginning of a new one. The true story of the Great Pyramid does not end with a British explorer's brushstroke. It begins there. Because the moment we admit that its authorship might be uncertain, we must confront the next question. When was it actually built? To answer that, we need to leave this 19th century scandal behind and follow the scientists who tried to measure time itself through carbon, stone, and light and discovered that the pyramid doesn't just defy forgery. It defies dating. Dating a structure made of stone sounds straightforward until you try. Stone contains no organic material, no carbon to measure, no clock to read. It does not decay, it endures. To science, it is mute. And so archaeologists have spent decades trying to make the pyramids speak in other ways through mortar, relics, and association. But each time they do, the evidence fractures into contradictions. The first serious attempt came in 1984 when Egyptologist Mark Lehner and a team of researchers funded by the Edgar Cayce Foundation undertook a radioarbon study of the pyramid's mortar. The technique known as carbon-14 dating measures the decay of radioactive carbon isotopes in once living material. Tiny remnants of straw, charcoal, or plant fiber embedded in the ancient lime plaster. Their results published in archaeology magazines seem to confirm the orthodox view. Dates clustered around 2500 BC, conveniently matching Khufu's supposed reign. Egyptologists celebrated the Great Pyramid, they said, had finally been scientifically dated. But a closer reading of the data tells another story. The samples varied wildly, some as much as 380 years older or younger than Khufu. One fragment even dated closer to 3000 BC, centuries before his dynasty. The team attributed the discrepancies to old wood, organic material reused from earlier generations. But that explanation, while tidy, glosses over a deeper problem. It assumes what it tries to prove. If the pyramid's date is already known, then the data must conform. If it doesn't, it's dismissed as contamination. Yet, the scientific reality is messier. Mortar represents not original construction, but maintenance. Over millennia, the pyramid has been repaired repeatedly by pharaohs, priests, and modern restorers. What the 1984 study actually measured could have been anything from patchwork repairs in the Old Kingdom to material inserted during medieval restoration. Carbon-14 doesn't tell us when the stone was laid, only when the last living fragment mixed into its mortar died. To put it simply, dating the mortar is like dating the dust on your bookshelf and calling it the age of your house. Later studies deepened the confusion. In the 1990s, researchers from the University of Zurich reanalyzed similar samples, again, finding broad discrepancies as much as 1,000 years apart. A few pieces even predated the entire Egyptian civilization as we know it. When independent researchers requested new samples to test, access was abruptly denied. Official statements cited preservation concerns. Unofficially, no one wanted more anomalies. Then in 2020, an accident in a Scottish museum changed everything. While cataloging old donations at the University of Aberdeen, curatorial assistant Air Eldani stumbled upon a small cigar box wrapped in a 1946 newspaper. Inside lay a splinter of cedar wood, dark, dry, and carved into a rod-like shape. A faded label read from the Great Pyramid Dixon relics. This was no ordinary souvenir. In 1872, British engineer Wayneman Dixon had discovered 3 small objects in one of the pyramid's hidden shafts. A granite ball, a bronze hook, and this very cedar fragment. The first 2 ended up in the British Museum. The wooden piece vanished for more than a century. When Eladani found it, she sent it for radiocarbon dating. The results stunned everyone. 351 to 340 BC. That makes the wood 5 to 8 centuries older than Khufu's lifetime. Older even than Egypt's first recognized pharaohs. The explanations came quickly. Some scholars claimed cedar trees could live for centuries. The wood might have been old when used. Others argued contamination, but the fact remains this is the only direct organic artifact found inside the pyramid structure, and it places the monument's material at least 500 years before its supposed builder was born. If true, that single splinter of wood could rewrite history, or more accurately, restore a version we've forgotten. If a single piece of wood could shake the foundations of Egyptian history, do you think that's possible? Leave a comment below. Do you trust the science, or do you believe there might be an entire chapter of history that was erased? Consider another case. At Saqqara, the step pyramid of Jose, officially older than Khufu's, shows erosion patterns strikingly similar to those on the Great Pyramid, even though its masonry is softer. If both experienced the same level of weathering, logic suggests they endured similar spans of time. But Egypt's dry climate can't account for the deep vertical channels cut into the stone. Those require centuries of heavy rain, the kind that ended around 5000 BC when the Sahara transformed from savanna to desert. That observation aligns with geological data. Sediment cores from the Nile Valley reveal high flood layers dating back more than 7,000 years when the region was far wetter. If the pyramid shows water erosion from that era, then its lower courses could predate Egypt's dynasties by millennia. Even its surroundings whisper the same story. Beneath the sand, archaeologists have found limestone pavements so heavily eroded, it suggests exposure to rainfall long vanished from the region's climate record. The Sphinx enclosure beside the pyramid displays the same telltale signatures, deep rounded grooves carved by water, not wind. Geologist Dr. Robert Schoch, after detailed stratigraphic study, concluded that the erosion occurred between 9000 and 7000 BC, an age consistent with the late Ice Age's final floods. If that's accurate, the Sphinx and the Great Pyramid belong not to Khufu's Egypt, but to an earlier world, one that disappeared when the Sahara dried and civilization rebooted. Still, orthodox archaeology resists this conclusion because it destabilizes everything built upon it. Not just Egypt's timeline, but humanity's. If the Great Pyramid is older than writing, then the history of civilization stretches back not 5,000 years, but perhaps 12,000 deep into the Younger Dryas when global sea levels rose and ancient coastlines drowned. The question then shifts from who built it to what were they trying to preserve. When engineers analyze the pyramid structure through luminescence dating, a method that measures trapped electrons in minerals to determine when stone was last exposed to sunlight, they found inconclusive results. Some blocks registered ages older than Khufu, others younger. Even the light trapped in its crystals refuses to confirm the official story. The pyramid resists measurement the way a mountain resists naming. And so scientists have begun to treat it as what it may truly be. A palimpsest built in layers across time. Perhaps an ancient core refurbished by later dynasties, repurposed as royal tomb, then as temple, then as symbol. A monument so old that each civilization simply claimed it anew. In that sense, Khufu may not have built the Great Pyramid at all. He may have merely inherited it, restored it, and left his name where earlier hands had long vanished. The carbon fragments, the cedar wood, the uneven data, all hint that beneath Egypt's known history lies a deeper, older foundation. The Great Pyramid, it seems, does not belong to any one era. It belongs to time itself. But if its age stretches back into the hazy twilight of prehistory, then the next question follows naturally: how was it built? Because the further we push its origins into the past, the less sense its construction makes until we are forced to confront an impossible reality. That the technology behind it did not simply precede Egypt, but perhaps preceded everything we know as civilization. Imagine standing on the Giza plateau more than 4 millennia ago, or perhaps far longer than that, watching thousands of men move in rhythm beneath the blazing Egyptian sun. Dust hangs in the air, drums beat, and ropes strain as stone blocks the size of buses inch forward across the sand. That's the picture we've been taught to believe. The power of human will against the immovable. The miracle of manpower building the impossible. But when we translate that image into numbers, into engineering, into real physics, the story begins to crumble. The Great Pyramid is not just big, it's mathematically absurd. It rises 146.6 m high, its base covering over 13 acres, an area large enough to fit St. Peter's Basilica, Westminster Abbey, and the cathedrals of Florence and Milan combined. Each side aligns almost perfectly to the cardinal directions. Its total weight about 6.5 million tons. To finish such a structure in 20 years, as textbooks claim, would require moving and setting 2.3 million blocks, averaging 2.5 tons each. That's roughly one stone every 2 minutes, 24 hours a day for 2 decades straight. Even today, with cranes, bulldozers, and laser-guided equipment, no construction project of that scale has achieved such speed and precision. Now, imagine doing it all with copper chisels and stone hammers. Copper measures 3 on the Mo hardness scale, while granite, the stone used for the pyramid's inner chambers, ranks between 6 and 7. In modern laboratory tests, copper chisels barely scratch granite before bending. Experimental archaeologist Dennis Stocks tried to replicate ancient cutting techniques. After hours of hammering, his team managed to cut a few millimeters into limestone, but the tools wore out faster than they cut. Against granite, they were useless. To shape just one of the 80-ton granite beams in the king's chamber, using such tools would require thousands of chisels, constant reforging, and months of labor per block. Multiply that by hundreds, and the logistics become unthinkable. Archaeologists have long suggested that the Egyptians used dolerite pounding stones to chip away at granite surfaces. But even dolerite is brittle. Photographs of ancient quarries at Aswan show circular pits and straight tool marks that look more like drilling than pounding. When engineers studied these grooves under magnification, they discovered spiral striations, the signature of a rotating tool, not a hammer. The grooves descend in continuous helical patterns consistent with a rotary drill bit, as if the stone had been carved by high-speed machinery. To test this, engineer Christopher Dunn, a precision manufacturing expert, created computer models of these marks. The result, the feed rate of the tool, how fast it cut through granite, was equivalent to a drill spinning thousands of times per minute, applying pressure far beyond what human hands could manage. In modern industry, similar marks appear only on materials shaped by diamond-tipped tools or ultrasonic cutting equipment. If ancient Egyptians achieved the same pattern with copper tubes and sand as orthodoxy claims, they would have needed centuries to complete the inner chambers. Transportation adds another layer of impossibility. Some granite beams inside the pyramid weigh up to 80 tons and were quarried in Aswan, over 800 kilometers to the south. How were they moved? The Nile would have offered a natural highway, but physics intervenes. The buoyant limit of a wooden barge of that size would be exceeded by even a fraction of that weight. Modern naval engineers recreated such a barge design in the 1990s. The moment they loaded it with 60 tons of granite, the vessel cracked and sank. Even if they managed to reach Giza by river, how were the stones hauled from the riverbank up the plateau? Orthodoxy proposes ramps yet to achieve the necessary incline for a smooth pull. Such ramps would have stretched for over a mile and contained more material than the pyramid itself. Not a single trace of such a ramp survives. Not foundations, not spoil heaps, not the massive quarries of clay required to build it. Some suggest a spiral ramp wrapping around the pyramid's exterior, but this too fails under scrutiny. A ramp curling upward would obscure the builder's sight lines, making precise corner alignment impossible. It would also require the removal of millions of tons of debris once construction ended, work for which no evidence exists. Modern experiments have tried to put these theories to the test. In 1978, the Nippon Television Corporation of Japan, working with Egypt's Supreme Council of Antiquities, set out to build a miniature replica of the Great Pyramid using only materials and techniques supposedly available to the ancients. Their pyramid would stand 20 m tall, a fraction of the original. From the start, it was a disaster. Copper chisels failed to shape even small limestone blocks. Ropes snapped. Workers couldn't drag the stones across sand without lubrication, so they poured water to reduce friction, an ancient technique hinted at in wall paintings. But the sledges still bogged down. Eventually, the team resorted to modern steel tools and diesel-powered cranes just to lift the smaller blocks. Even then, their pyramid reached only 10 m, half their target, before the project was abandoned. The conclusion, quietly noted in their final report, was that no known ancient technique could account for the precision or scale of the Great Pyramid's construction. To match the precision of Giza today, engineers would need laser alignment systems, GPS calibration, and hydraulic cranes capable of lifting 100 tons. Yet somehow, According to mainstream history, Bronze Age builders accomplished it with nothing more than rope, wood, and human sweat. Let's pause to visualize it scientifically. Each side of the Great Pyramid measures 230.4 m, and the difference in length between its longest and shortest sides is less than 2 centimeters. The base is leveled to within 1.5 centimeters across 13 acres. A level of precision equivalent to modern high-rise construction. The structure's orientation to true north deviates by just 3 minutes of arc 0.05 dig. Even the Hubble Space Telescope, built with computers and lasers, has a manufacturing tolerance in the same range. How does a Bronze Age society achieve accuracy rivaling modern aerospace engineering? Some researchers have proposed imaginative but testable hypotheses. The pyramid's geometry, its angles and proportional ratios suggest that the builders understood not only geometry but also geodesy, the curvature of the Earth. The base perimeter multiplied by 43,200 equals Earth's equatorial circumference. Its height multiplied by the same number gives the polar radius. These relationships are not arbitrary. They require knowledge of the planet's size, shape, and axial tilt. If the builders knew such measurements, they also possessed advanced surveying methods. But how? No evidence of such instruments survives from Khufu's era. Could it be that the pyramid we see is a reconstruction, a renewal of something older, built with tools or techniques since lost? The Egyptians themselves seem to believe so. In temple inscriptions from Saqqara, priests describe records of the first time and plans of the ancestors, suggesting that the blueprints for these monuments were inherited rather than invented. The paradox grows clearer the more we look. The Great Pyramid is both simple and impossible. 4 triangles on a square base, yet executed with precision that humbles modern engineers. Its construction required understanding of mathematics, logistics, and material science that defies its alleged age. So, if it wasn't built by 4th dynasty Egyptians with copper tools and sweat alone, then how was it built? Stand at the base of the Great Pyramid, and it's easy to be overwhelmed by its scale. But step closer, trace your hand along its surface, and something far stranger emerges. What first looks like rough weathered stone becomes a study in impossible precision. Each block fits its neighbor with surgical accuracy, the seams between them thinner than a sheet of paper. For centuries, scholars have tried to explain how Bronze Age masons could produce such perfection. Yet, every answer dissolves beneath the evidence, leaving only the paradox itself. The oldest monument on Earth is also its most precise. Let's start with the measurements. When 19th century surveyor Flender Petrie, one of the most meticulous field scientists of his time, took his instruments to Giza, he expected imperfections. What he found astonished him. The base of the Great Pyramid covers more than 13 acres, yet the height difference between its corners is less than 2 centimeters. The 4 sides deviate from true north by a mere 3 minutes and 6 seconds of arcade. That's 1/120th of a single degree. Even with GPS and lasers, modern engineers rarely achieve this on a project of that scale. How then could people working with rope, plumb bobs, and copper chisels produce such alignment? Egyptologists suggest that surveyors observed the stars using the pole star Thuban in Draco to mark north. But astronomers have calculated that in 2500 BC, Thuban lay slightly off true north, enough to create a larger deviation than the pyramid shows. In fact, the Great Pyramid's orientation is more accurate than observatories built 4,000 years later. The deeper you go, the stranger it gets. The casing stones that once covered the pyramid, most now removed, were cut so precisely that modern restorers struggle to replicate them. Some joints measure less than half a millimeter, their surfaces polished to optical flatness. Engineers from the French Institute for Research in Engineering and Construction studied surviving casing blocks in the 1990s and found tolerances comparable to precision machined metal. One engineer described it as the accuracy of an airplane wing applied to millions of tons of rock. The foundation stones beneath the visible layers display similar mastery. Ground-penetrating radar shows interlocking bedrock terraces engineered to distribute weight evenly across the plateau. The result, after thousands of years of earthquakes, sandstorms, and temperature swings, the pyramid has not settled or shifted more than a few millimeters. To achieve that stability, its builders must have understood both load distribution and material expansion coefficients, concepts formalized only in the last few centuries. Even the internal architecture obeys laws of precision unknown to its supposed era. The Grand Gallery, a 47-me passage rising toward the king's chamber, is constructed of granite blocks fitted so tightly that air cannot pass between them. The slope of the gallery, 26 degrees, matches exactly the angle of the pyramid's outer face, suggesting intentional harmonic resonance. The gallery's corbelled ceiling, each course projecting a few cm inward, reduces structural stress with mathematical efficiency. Such a technique wasn't rediscovered in modern engineering until the development of cantilever principles in the 19th century. And then there are the tool marks, tiny signatures carved into the stone. Inside the pyramid, on the granite beams of the king's chamber, lie spiral striations consistent with mechanical drilling. Engineer Christopher Dunn, a master machinist, measured the grooves and found a uniform pitch, meaning the cutting head advanced at a fixed rate as though driven by a lathe or rotary drill operating thousands of revolutions per minute. Laboratory tests using copper and sand drills failed to reproduce those patterns. The modern experiments left rough, irregular scratches, not the clean concentric rings visible on the ancient stone. The same precision appears on blocks at nearby temples. At Abydos, granite boxes cut from single pieces of stone show interior angles meeting at perfect right angles, verified by modern laser alignment tools. Their surfaces are flat to within 1/10,000th of an inch, a standard used today in aerospace manufacturing. Yet these artifacts are attributed to dynasties that supposedly lacked iron tools or advanced measuring instruments. To dismiss these anomalies as coincidence is to ignore the sheer consistency of precision across the site. Every block in the pyramid, millions of them, fits into a geometry so exact that when the structure was intact, the height-to-base ratio encoded the mathematical constant p to 3 decimal places. Its side angles embody the golden ratio found throughout nature and later in the art of Da Vinci. The precision wasn't random. It was systemic, as if every dimension followed a unified design code. So, how did they do it? The orthodox answer insists on simple tools, copper chisels, wooden mallets, dolerite pounding stones. But in repeated reconstructions at the Aswan quarries at Saqqara, at the Japanese experiment in 1978, these tools fail spectacularly. Copper bends, dolerite shatters, and manual polishing produces nothing close to the measured flatness of Giza's granite surfaces. Other explanations verge on the speculative but remain grounded in physics. Some engineers proposed that the builders used abrasive slurry saws, copper blades combined with quartz sand and water to grind through granite. While plausible for small pieces, scaling the technique to 80-ton beams is unrealistic. Others suspect vibration cutting, harnessing sonic frequencies to fracture the crystal lattice of granite. Experimental ultrasonic machines today can slice through hard stone with surprising ease. But such technology belongs to the 20th century, not the 26th BC. Then there's the possibility that the builders didn't cut each stone individually at all, but cast them using a lost form of limestone geopolymer, a kind of ancient concrete. French materials scientist Joseph Daviditz proposed this in the 1980s, arguing that some outer blocks show microbubbles and binding textures consistent with reconstituted stone. If true, it would imply an advanced knowledge of chemistry and materials engineering. But when samples from deeper core blocks were tested, the results pointed back to quarried, not cast stone. The mystery endured. Perhaps the real secret lies not in tools or materials, but in intent. The pyramid's geometry is not random. It is tuned. Acoustic tests reveal that the king's chamber resonates at 440 to 432 Hz, the same frequencies used to tune musical instruments and matching Earth's own electromagnetic resonance. When sound is introduced, the entire chamber vibrates like the body of a colossal instrument. Was this precision a byproduct of artistry or part of a design that harnessed vibration, sound, or energy in ways we barely understand? Even the choice of materials seems deliberate. The outer casing of high quartz limestone reflects sunlight while the inner granite core rich in quartz and feldspar conducts and amplifies vibration. Modern engineers have noted that this combination creates so-electric effects, tiny electrical charges generated by mechanical stress. If that property was known and exploited, the pyramid might not have been a tomb at all, but a kind of resonant device using precision itself as a form of power. Whatever the explanation, the paradox remains. How did the first great monument of civilization display the last word in precision? Every subsequent pyramid is worse, less aligned, less stable, less sophisticated. History should move the other way. Technologies evolve through trial and error. But at Giza, perfection appears first and declines after. That inversion suggests inheritance rather than invention. A monument built by a culture whose mastery was already ancient, whose knowledge of measurement and geometry came from a deeper lineage now lost. Step inside the Great Pyramid and the sunlight dies instantly. The air turns cool and still. The walls swallow sound and darkness folds around you like a second skin. You can feel the weight of millions of tons above your head. Yet the silence is absolute. You reach out to trace the walls perfectly straight, perfectly smooth. And then comes the question every visitor eventually whispers, how did they see and hear? Because to carve this geometry in total darkness seems impossible. If torches or oil lamps had been used, the ceiling should be blackened with soot. Yet from the descending passage to the king's chamber, not a single smear of carbon residue exists. The limestone and granite are pristine, their pale surfaces untouched by smoke. Even microscopic analysis of the interior performed by the University of Cairo's Department of Archaeology confirms that the stone pores contain no trace of combustion byproducts, no unburned hydrocarbons, no lamp ash. This absence is so complete that it borders on eerie. Other tombs and temples from the Old and Middle Kingdoms show exactly what one would expect. Blackened ceilings, soot-crusted into corners, scorch marks from years of flickering flame. The tomb of Seti, the one in the Valley of the Kings, for instance, is a gallery of soot-stained beauty. Yet the Great Pyramid, supposedly built 1,000 years earlier, is immaculate. So if not flame, what brought light to the darkness? The traditional explanation is the mirror theory that sunlight was reflected deep into the pyramid through a series of polished bronze mirrors. Egyptologists still repeat this idea, but physics disagrees. Even the best polished bronze reflects less than 40% of incident light. After just 3 or 4 reflections, the beam would lose nearly all its intensity, fade into nothing long before reaching the interior chambers. To test this, physicist Dr. John Baer of Oxford recreated a scaled mirror system in 2016. His experiment showed that by the 4th reflection, less than 3% of sunlight survived. The faint glow was insufficient to illuminate a worker's face, let alone the sharp chiseling required to smooth granite. Moreover, no archaeological trace of such mirror systems has ever been found. No mounting brackets, no polished discs, no fragments. The mirror theory, like torch light, burns out quickly. Other hypotheses suggest the Egyptians used oil lamps with filtered wicks or fat-based fuels designed to burn cleanly. Yet, chemistry exposes another flaw. Even low smoke oils produce measurable soot over time. The longer a lamp burns, the more carbon accumulates. The Great Pyramid's untouched ceilings tell us that no open flame ever illuminated its passages. But what if the builders didn't rely on fire at all? Deep within the Temple of Hathor at Dendera, over 400 kilometers south of Giza, lies a relief that has puzzled archaeologists for decades. It depicts priests holding what appear to be elongated bulbs, each containing a serpent-like form and connected by a cable to a box-like object. Some researchers interpret these as stylized symbols of creation, but others, including electrical engineer Eric von Den, have suggested that the relief represents an ancient lighting device, what he called the Dender light. When engineers built a physical model of the bulb using materials available in antiquity, quartz, copper, and acid electrolyte, it produced a faint glow similar to a low-voltage discharge tube. To mainstream science, this remains speculative. Yet, intriguing chemical residues inside the Dender Temple's crypt chambers show traces of zinc and sulfur compounds, the byproducts of galvanic reaction. Coincidence? Perhaps, but it hints at an ancient awareness of energy far beyond what textbooks allow. Now, consider the Great Pyramid's materials. Its core and inner chambers are constructed of Aswan granite, which contains high levels of quartz and feldspar minerals with zooelectric properties. When subjected to pressure or vibration, these crystals generate a small electrical charge. Surrounding that granite are the outer casing stones of white limestone, a strong electrical insulator. In modern engineering, this combination, an inner conductor wrapped in an insulating shell, forms a resonant cavity capable of concentrating and amplifying energy. Could the pyramid itself have functioned as a massive resonant structure? An energy transducer converting vibration into electricity or light. In 2018, physicists at ITMO University in St. Petersburg working with the laser Zentrum handover modeled how electromagnetic waves interact with the pyramid's shape. Their simulations revealed that at certain resonant frequencies, the internal chambers and the area beneath the pyramid's base concentrate electromagnetic energy in the core and foundation. The study published in the Journal of Applied Physics concluded that the geometry of the pyramid allows it to focus and amplify naturally occurring electromagnetic waves. This does not prove that it glowed like a light bulb, but it raises an intriguing possibility. Perhaps illumination wasn't provided by fire or reflection, but by resonance. The evidence isn't limited to mathematics. When modern acoustic researchers tested the king's chamber, they found something extraordinary. It hums. At frequencies between 110 and 120 Hz, the granite walls begin to vibrate audibly. When that sound harmonizes with lower frequencies, especially around 8 Hz, the Schumann resonance of Earth's electromagnetic field, the entire chamber becomes a resonant cavity. In the darkness, the granite subtly glows under infrared cameras, heated not by flame, but by vibration. To the builders, this may not have been technology as we know it, but sacred physics, the harnessing of sound, energy, and geometry to create light, power, or even altered states of consciousness. Ancient Egyptian texts describe the gods as those who shone with light and refer to the priestly caste as keepers of the luminous flame that burns without smoke. These are poetic phrases, yes, but what if they preserve memory of something literal? Archaeologists have found other hints that Egypt's earliest temples were built for resonance rather than ritual. In the underground Serapim of Saqqara, massive granite sarcophagi, each weighing up to 70 tons, resonate like tuning forks when struck. In the Oran at Abydos, chambers carved directly into bedrock produce identical low-frequency vibrations. Acousticians call these standing waves. Ancient builders may have used them intentionally, amplifying sound and light in ways we barely comprehend. Some historians dismiss these findings as pseudoscience, yet they overlook one fact. The precision required to create such resonant spaces matches the precision of the pyramid's construction itself. Every angle, every chamber, every shaft seems tuned, as if the entire structure were an instrument, not a tomb. When visitors today play a low tone inside the king's chamber, they often describe a tingling in their skin, a lightated sensation, even flashes of brightness at the edge of vision. Some call it imagination, others call it induction. Either way, the experience suggests that the Great Pyramid interacts with the human body on frequencies we rarely sense. So perhaps the light of the pyramid was never visual. Perhaps it was something deeper, an illumination of the mind, an awakening of perception triggered by resonance, a way to make those who entered see without seeing. Whatever its function, one thing is clear. The Great Pyramid was not built merely to house a corpse. Every measurement, every material, every chamber serves a physical and mathematical purpose. And if that purpose involved light, energy, or resonance, then we are not dealing with primitive builders. We are dealing with a civilization that understood the language of the earth itself. In the next part, we step out of the darkness and back into daylight to the kings who claimed these monuments as their own. For what if the Egyptians didn't build the Great Pyramid at all, but simply found it waiting, already ancient, already glowing in the sun, and rewrote history to make it theirs? When we walk through the grand halls of Egyptian museums, every statue and stele bears a familiar pattern. Rows of hieroglyphs declaring who built what, who ruled, who conquered. Names carved deep into stone as if to anchor themselves against time. Yet if you look closely, you'll see something odd. Many of those names have been carved over others. Beneath Ramses, another faint script. Beneath Seti, another cartoon half erased. The Egyptians were masters not only of construction, but of appropriation. They didn't just build monuments, they inherited them and rewrote them. This practice had a name: usurpation. In modern language, it means to take by force. But to an ancient Egyptian, it meant continuity. A pharaoh stepping into the power of his divine predecessors. To carve over an older name was not desecration, but sanctification. Yet through this ritual rewriting, truth itself became blurred. Temples, statues, even gods were rebranded. Over centuries, one dynasty after another polished out the past and etched in its own reflection. Nowhere is this clearer than in the reign of Ramses, the known as Ramses the Great, the builder pharaoh. His likeness dominates Egypt. Colossal seated statues, temples rising from cliffs, inscriptions celebrating him as the architect of all wonders. But archaeology tells a quieter story. Ramses built much, yes, but he also claimed more than he constructed. At Abydos, Ramses' inscriptions sit atop the reliefs of his father, Seti I, chisels having scraped away older hieroglyphs. At Luxor Temple, his cartes appear over those of Amenhotep III, whose massive statues Ramses simply renamed. Even the Great Temple of Abu Simbel, attributed entirely to Ramses, shows signs of modification rather than original creation. The stonework beneath the newer reliefs is eroded, ancient even in his time. The pharaoh who sought eternal fame may have achieved it by stamping his identity over the memory of those who came before. If usurpation was common practice during Egypt's later dynasties, could it also have happened in the 4th dynasty or before? Let's return to the Great Pyramid. The single piece of proof connecting it to Pharaoh Khufu is that red cartoon found by Howard Weiss, painted in haste, misspelled, and suspiciously modern. Outside those few marks, not a single inscription anywhere names Khufu as the builder. No temple reliefs show his workers hauling limestone. No papyrus describes the construction. No statue commemorates the achievement. For the greatest architectural project in human history, there is silence. Meanwhile, the smaller pyramids nearby, supposedly built later, do carry inscriptions, even decorative chambers filled with texts and art. The oldest and largest, paradoxically, is also the most anonymous. Archaeology offers another clue. The recycling of monuments across Egypt, entire temples were rebranded. The step pyramid of Djoser at Saqqara, hailed as the first pyramid, was expanded and modified by later kings. Its core structures, however, predate Jose himself. The Oran at Abydos, a massive subterranean complex carved from granite blocks, lies 20 feet below Seti the Worm's temple and shows water erosion far older than his reign. Seti's builders simply incorporated it, carving hieroglyphs on the already ancient walls and claiming it as their own. Even in the shadow of the Sphinx, evidence suggests layered ownership. Restoration inscriptions from Thutmose IV describe him awakening the monument from the sand after it had lain buried since the time of the ancestors. His dream steelly makes no claim of building the Sphinx, only of rediscovering it. He calls it Kir-Ra, the becoming of the sun, as though the statue already held divine significance long before his time. To archaeologists, this isn't scandalous. It's standard practice. Dynasties inherited, renovated, repurposed. But when applied to the Great Pyramid, the implications are staggering. If Khufu merely refurbished or re-sanctified an existing monument, adding his name, his mortuary temple, and his royal causeway, then the pyramid could be thousands of years older than his reign. Its original builders, whoever they were, had long vanished. Egyptian priestly texts hint at such a scenario. The ancient chronologist Manetho, writing in the 3rd century BC, described Egypt's history as a sequence of ages. The reigns of gods, demigods, and finally mortal kings. The divine rulers, the Shemsu or followers of Horus, reigned for thousands of years before Menes unified Egypt around 3100 BC. To the priests of Heliopolis, this earlier epoch was known as Zept, the first time, an age when gods walked the earth and built sacred structures aligned with the heavens. Modern Egyptologists label Zepi as myth. Yet myths often encode memory. In Sumer, similar stories speak of kings who ruled for tens of millennia before the flood. In India, the Sanskrit texts describe previous yugas, cycles of rise and collapse long before our recorded age. The consistency of these traditions suggests that the idea of a first civilization was not fantasy, but ancestral recollection. And so we face a provocative question. Was Khufu's Egypt the inheritor, not the inventor of the pyramid tradition? Consider how later Egyptians treated the Great Pyramid. For them, it wasn't a tomb, but a temple of mystery. During the Greek and Roman periods, priests and scholars entered its chambers seeking divine knowledge. They called it the Pillar of Enoch or the Sanctuary of Teach. Islamic chroniclers later referred to it as a repository of ancient wisdom built before the flood. Even the 10th century historian Al-Maksi wrote that the pyramids were constructed by a pre-dynastic king to preserve knowledge from a coming cataclysm. Each generation, it seems, layered its own interpretation upon the monument, rewriting not just who built it, but what it meant. The pharaohs carved their names. The Greeks turned it into philosophy, the Arabs into legend. In each retelling, the true builders slipped further into shadow. The irony is that modern archaeology continues the same tradition. We too rewrite the past to fit our comfort. We accept Vis's painter's proof, ignore anomalies that don't align, and declare the mystery solved because it must be. To admit uncertainty is to unmoor history itself. But the stones don't lie. Their precision, their erosion, their silent geometry all point toward an origin beyond Khufu's time. The Great Pyramid is not an isolated marvel of Egyptian ambition. It is the echo of something older, the blueprint of a forgotten age rebranded by those who came later. If Khufu was not the builder, then who was? And what knowledge did that earlier civilization possess to shape stone with such impossible mastery? To answer that, we must turn to the language of the builders themselves. A language not written in hieroglyphs, but in numbers and stars. Because carved within the dimensions of the Great Pyramid is a message from a vanished world. A mathematical code that still speaks across time. Under the desert moon, the Great Pyramid of Giza seems less a monument than a formula. A vast equation carved into the earth. Its angles rise with purpose. Its sides align with the stars. Its proportions whisper of balance and order. For those who study it closely, the stones begin to speak a different language. Mathematics. Not the arithmetic of merchants or scribes, but something older and universal. The geometry of the cosmos itself. This perhaps is where the true mystery of the pyramid lies. Not in how it was built, but in what it knows. Let's begin with a simple but astonishing fact. When modern engineers measured the pyramid's base and height, they discovered a ratio that seemed impossible for the time. If you take the perimeter of its base and divide it by twice its height, you get 3/1416, the value of p, accurate to 4 decimal places. The same constant that defines the relationship between a circle's circumference and its diameter appears perfectly embedded in a structure made of straight lines and flat planes. But how could a Bronze Age culture have known p so precisely? The earliest written approximation of p found in the Ren mathematical papyrus dates to around 1 to 150 BC, a full 1,000 years after Khufu. Even then it was only an estimate 316. Yet the Great Pyramid built long before that text encodes the true value within its geometry. Coincidence? Unlikely, because p is not the only constant hidden within the stones. The pyramid also embodies the golden ratio F to Oscus 1.618. The same proportion found in spirals of shells, petals of flowers, and the arms of galaxies. When you divide the slant height of the pyramid by half its base, the result is precisely F. The structure fuses P and F, the mathematics of circle and line, infinity and form. To ancient builders, this wasn't merely clever geometry. It was theology in stone, the union of heaven and earth expressed through proportion. Archaeologists once assumed this precision was accidental, the byproduct of practical design. But satellite measurements have shown that these ratios recur throughout the complex. The smaller pyramids of Khafra and Menkaure follow similar harmonic relationships scaled down as if by musical intervals. This harmony extends to the Sphinx, whose alignment complements the pyramid's geometry with eerie precision. The monument seems to have been laid out not as a building but as a harmonic system. When researchers began to apply astronomical analysis to these ratios, the mystery deepened further. The Great Pyramid's latitude is 29,979,2458 Dale N, a number that almost exactly matches the speed of light in meters/s. 299,792,458 NOS. The precision is uncanny, a match to the 6th decimal place. Skeptics point out that the metric system didn't exist in antiquity. True, but the alignment remains curious because latitude is a function of Earth itself, not human measurement. Whether the match is coincidence or a hint of ancient knowledge of Judaism, it adds another layer to the pyramid's cosmic precision. The monument is also oriented to true north with staggering accuracy off by less than 3 arc minutes. A want is almost 20th of a degree. To achieve that, the builders would have needed a method to measure precessional drift, the slow wobble of Earth's axis that changes the position of the celestial pole over thousands of years. Yet precession wasn't scientifically recognized until Hipparchus of Greece discovered it in 130 BC, over 2 millennia later. Even stranger, the pyramid's 4 sides are subtly concave, bowed inward by an average of 37 inches. This feature is invisible from the ground, only discernible from the air. As first noticed during a 1940 Royal Air Force survey, the concavity precisely matches the curvature of Earth's surface at Giza's latitude. In effect, the pyramid models both the shape and scale of the planet, implying an understanding of Earth as a sphere. Knowledge not formally proven until 2,000 years later. Inside, the same mathematical language continues. The dimensions of the king's chamber, 10 cubits wide, 20 long, and 11 high, are a perfect double square rectangle. This one ratio generates the frequencies associated with musical harmony. When sound is produced inside the chamber, the granite resonates at 440 and 432 Hz, tones that correspond to modern concert pitch and the so-called natural resonance of the Earth. This is not coincidence. Ancient Egypt's temples, including Abydos and Dendera, exhibit similar resonant geometries. Stone-carved halls amplify specific frequencies, sometimes causing the entire structure to vibrate like a tuned instrument. The pyramid's designers understood that form and frequency are connected, that geometry can shape sound, and sound can shape consciousness. In 1998, acoustic engineer Tom Danley recorded standing waves inside the king's chamber that behave like those in a musical instrument. The chamber's resonance amplifies low tones, generating patterns of vibration that pulse through the stone itself. Modern imaging reveals interference nodes where the frequency builds, creating invisible fields of pressure. To the ancients, this might have been perceived as the voice of the gods, the living breath of the structure. The same harmony exists on a planetary scale. Multiply the pyramid's height by 43,200 and you get 657,000 m, the exact polar radius of the Earth. Multiply its base perimeter by the same number, and you get 40,30,000 m, the planet's equatorial circumference. The odds of such precision by chance are astronomical. The number 43,200 is itself no accident. It is a multiple of 86,400, the number of seconds in a day. It encodes not just the size of the Earth, but the rhythm of its rotation. Whoever designed the pyramid didn't simply build a monument. They built a scale model of our planet. To achieve this, they must have known both the circumference of the Earth and the concept of a spherical world. Discoveries attributed to Eratosthenes in 240 BC. Yet, the pyramid predates him by more than 2,000 years. So, did ancient Egyptians independently calculate these measurements? Or did they inherit this knowledge from a culture far older, one capable of mapping the globe with astronomical precision? The pyramid's geometry also encodes celestial cycles. The angle of its sides 50 degrees and 50 inches mirrors the angle of Earth's orbital tilt. 50 from to the plane of the ecliptic. Its alignment with the Orion belt and the star Sirius reflects the same sky visible around 10,500 BC, long before Egypt's dynasties began. The builders weren't simply observing stars. They were documenting time on a scale of millennia, freezing the heavens in stone. Even the mathematical constants P and F have deeper symbolism. In sacred geometry, PT represents infinity, the circle with no beginning or end. F represents life, the generative proportion through which matter self-organizes. Together they embody creation, the eternal and the living. The pyramid then can be read as a universal equation. Life unfolding from eternity. This understanding appears in myths worldwide. The Mayan pyramid of Kukulkan at Chichen It encodes the solar year in its 365 steps. The temples of Angkor Wat in Cambodia align with precessional cycles spanning 25,920 years, the same great year known to ancient Egyptians. Across continents, the same constants, the same celestial ratios repeat as if all these builders were reading from a single manual, the mathematics of the gods. Modern scientists call this coincidence, but coincidence begins to sound like language when it repeats with precision. If the Great Pyramid truly encodes the constants of the earth, the heavens, and the laws of vibration, then it is not merely architecture. It is data preserved through geometry. A message not written in ink but in proportion. And if so, it may be the oldest scientific document in human history. A stone record from a civilization that understood the universe as number, sound, and light long before our own equations rediscovered the same truths. In the next part, we lift our gaze upward to the stars that seem to mirror the Giza Plateau itself. For the pattern of Orion's belt etched across the sky may not be an accident of myth, but a cosmic blueprint, the key to understanding when, and perhaps by whom, this pyramid was truly aligned. When night falls over the Giza Plateau, the desert becomes a sea of silence. The air cools and stars spill across the black sky. Countless points of light, ancient and eternal. From this height, standing before the Great Pyramid, the horizon seems to bend. The monument's apex points upward like a compass needle. And suddenly, you begin to understand. This entire complex wasn't built merely for the earth. It was built for the heavens. For thousands of years, the Egyptians called their land Tart Meri, the beloved land. But they also called it Jessa, the sacred land of the gods. To them, the sky wasn't a void. It was a mirror of the divine world, a celestial Nile flowing above the earthly one. And the Great Pyramid was the meeting point, the axis where heaven and earth touched. In 1993, engineer and researcher Robert Bovell made an observation that changed how we see Giza forever. Studying aerial photographs of the pyramids, he noticed something peculiar. The three pyramids weren't arranged in a perfect line as most assumed. The smallest, that of Menara, was offset slightly to the south. It was a detail few had questioned until Bovell realized that the same offset appears in the three stars of Orion's belt, Al-Nitak, Al-Num, and Mtaka. When he overlaid the map of Orion onto the pyramid plan, the alignment was nearly perfect. The relative positions and sizes matched, the largest star to the largest pyramid, the smallest to the smallest. It wasn't mere resemblance, it was precision. Even the offset direction corresponded. The Giza Plateau, it seemed, was not random architecture, but a celestial reflection, a map of Orion laid onto the sands of Egypt. But Bovell's discovery didn't stop there. Using astronomical software, he calculated the position of Orion's belt across millennia, adjusting for axial precession, the slow wobble of Earth's rotation that shifts the apparent position of the stars over time. When the stars of Orion were aligned precisely with the pyramids, the clock of heaven pointed to 10,500 BC. That date doesn't just fall outside Khufu's reign. It precedes Egypt itself. It lands near the end of the Younger Dryas, a period of global cataclysm, massive flooding, abrupt climate shifts, and the extinction of Ice Age megapora. It's also the same era when other mysterious monuments go in Turkey, the Sphinx's eroded body, and ancient flood layers in Mesopotamia seem to converge. Could the builders of Giza have been commemorating an earlier sky? A celestial memory of a world destroyed. Mainstream scholars resisted Bovell's conclusions, arguing that the alignment was coincidence. Yet, the coincidences multiplied. The pyramid's relative brightness matches that of Orion's belt. Khufu's pyramid corresponds to the brightest star, Al-Nitak. Khafra's to Al-Num. Manaris to Minta, the faintest. Their layout mirrors not only Orion but its declination angle relative to the Milky Way. When viewed from above, the Nile runs across Giza exactly as the Milky Way does across Orion in the ancient sky, a celestial river reflected on Earth. The Egyptians themselves called the Milky Way the winding waterway of the gods. The dead were believed to sail along it after death, guided by the constellation Sar, the divine name for Orion, toward eternal life. In this cosmic mythology, Orion represented Osiris, god of rebirth, while the bright star Sirius nearby symbolized his consort, Isis. Each year, Sirius's rising before dawn heralded the flooding of the Nile, the rebirth of Egypt itself. Now look again at the pyramid shafts. The southern shaft from the king's chamber points directly to Orion's belt. The northern shaft to the pole star Thuban. Meanwhile, the queen's chamber's southern shaft targets Sirius and its northern one points to Khutshab in Ursa Minor. These alignments are not random tunnels. They are cosmic sightlines connecting the earthly realm of kings to the heavens of gods. To the Egyptians, this wasn't architecture. It was resurrection technology. The pharaoh's spirit upon death was believed to ascend through these shafts, traveling along beams of starlight toward Orion, the realm of Osiris, where he would be reborn among the stars. The pyramid itself was a machine for immortality. But the precision of these alignments suggests that whoever designed them understood the sky not as priests or poets, but as astronomers. They had to measure stellar declinations with an accuracy of less than 1 arc-minute, a feat requiring instruments that wouldn't reappear until the Renaissance. They also had to account for precession, a phenomenon invisible to a single lifetime, taking 26,000 years to complete one cycle. So, how could a civilization supposedly born in 3000 BC have encoded a sky from 10,500 BC? A pattern visible only at the end of the Ice Age. Either they possessed knowledge inherited from an older world or the pyramids themselves were built in that earlier age, preserving a snapshot of the heavens that once shone above a different Earth. Evidence for that inheritance lingers in myth. In Egyptian cosmology, Zepi the first time marked the era when the gods descended from the stars to establish order after a cosmic flood. Osiris ruled the earth teaching mankind civilization until disaster struck and he was slain by his brother Set. Isis resurrected him briefly, conceiving their son Horus, who later avenged his father and restored the divine order. To Egypt's priests, the rising of Orion each year symbolized that same resurrection. A story of destruction and renewal written in the stars themselves. Could the myth of Osiris encode memory of a real event? A cataclysm that destroyed a primordial civilization whose survivors rebuilt along the Nile. If so, the Giza complex might not just imitate the heavens. It might commemorate them. A cosmic memorial to the world before the flood. Astronomical modeling strengthens the link. When the Orion alignment at Giza peaked around 10,500 BC, the constellation Leo rose due east, directly where the Sphinx faces. The lion-bodied statue weathered by ancient rains may symbolize the age of Leo, the same epoch when Orion's alignment was perfect. Together, the Sphinx and the pyramids mark a celestial time stamp, a double signature of time and myth. Across the world, similar patterns appear. The temples of Teotihuacan in Mexico align with Orion's belt. The complex's central avenue mirrors the Milky Way. The megaliths of Napa in southern Egypt dated to around 6000 BC align with both Orion and Sirius thousands of years before Khufu. Ancient builders everywhere seem to have looked up and built down, mapping heaven onto Earth. Were these parallel evolutions or the echoes of a single global knowledge system, a prehistoric science of the sky that predated recorded history? Even modern astronomy can't fully dismiss the precision of Giza's stellar design. When NASA physicists mapped the pyramid's coordinates against Earth's axial tilt and the orbital plane of Orion, they found geometric relationships that repeat at scales of both planetary and galactic proportion. As if the builders had encoded not only where they were, but when they were. Whatever the explanation, one truth remains. The Great Pyramid isn't a tomb frozen in stone. It's a clock, one that measures epochs, not years. Its geometry and alignments trace the turning of the heavens across millennia. And if it does point back to 10,500 BC, it may hold the memory of a lost chapter in human history, a civilization wiped from the surface, but not from the stars. In the next part, We'll step inside that silent heart of stone, the so-called King's Chamber, to confront another mystery. A chamber with no inscriptions, no treasures, and no body. What purpose could such emptiness serve in a structure built with such cosmic precision? You step into the King's Chamber, and the world outside dissolves. The air is heavy, metallic, still. The granite blocks press inward with a weight you can feel in your bones. There are no paintings, no carvings, no inscriptions, nothing that identifies the room as the resting place of a pharaoh. Only a rectangular granite box sits near the western wall, lidless and hollow, like an echo waiting for a voice. This is supposed to be Khufu's tomb, the culmination of Egypt's most ambitious monument. Yet where other royal chambers overflow with hieroglyphs, gold, and ritual text, this one is naked. Its silence feels intentional, almost defiant. Archaeologists call it austerity. Others call it amnesia, but perhaps it's something else entirely. Let's start with the obvious contradiction. No human remains have ever been found inside the Great Pyramid. Not a bone, not a fragment of coffin, not even resin from mummification. The granite box, often called the sarcophagus, is empty, and its interior shows no sign of ever holding a body. The box itself is too large to fit through the narrow passageways, meaning it had to be placed there during construction, long before the pyramid was sealed. But if it was made for a royal burial, why install it before the mummy existed and leave no lid, no inscriptions, no offerings? Compare this to the tomb of Tutankhamun, discovered untouched in 1922. Walls covered in sacred text, rooms packed with 5,000 artifacts, the air still thick with the scent of oils after 3,000 years. That is what a pharaoh's tomb looks like. The Great Pyramid, by contrast, feels less like a burial and more like a chamber of calculation. The deeper you examine its architecture, the more the tomb theory collapses. The internal passages form a layout unlike any known Egyptian burial. The grand gallery rises with the symmetry of a machine housing, its corbelled walls tapering upward as though designed to channel or contain force. Above the King's Chamber, 5 relieving chambers distribute pressure through interlocking granite beams. An extraordinary feat of load management. For a simple tomb, such engineering is absurdly excessive. It's like constructing a nuclear reactor to protect a single coffin. Then there's the acoustics. Sound behaves strangely here. A low hum set off inside the King's Chamber reverberates through the granite until your chest vibrates with it. At 440 Hz, the modern musical of the chamber resonates naturally. But at 432 Hz, that resonance becomes profound, generating standing waves that travel the length of the structure. Microphone tests reveal harmonic frequencies that match those of the Earth's natural vibration, the Schumann resonance. Again, it's as though the chamber was tuned to the planet itself. When physicist Tom Danley performed sonic mapping in 1998, he found that the chamber amplifies frequencies between 90 and 120 Hz, a range associated with low vibrational states that affect human perception. People inside often describe feeling a sense of expansion, disorientation, even altered consciousness. Whether psychological or physical, the effect is real. Was this deliberate? If so, the pyramid may have functioned as a kind of resonant temple designed not for the dead, but for the living, a space where sound, vibration, and geometry merge to induce states of transformation. The Egyptians believed the soul or Kai could travel between worlds through harmonics of sound. Priests chanted in specific tones, believing these frequencies opened pathways to the divine. Could the Great Pyramid have been the ultimate instrument of that belief? An acoustic gateway? Recent ground-penetrating radar surveys show even more complexity. Beneath the King's Chamber lies the so-called subterranean chamber, an unfinished cavity deep below the pyramid cut directly into bedrock. It's oddly shaped, asymmetrical, and seems to serve no burial purpose. Some speculate it was part of a resonance system, a counter-chamber to balance vibrations above. Others think it's older than the pyramid itself, a remnant of an earlier phase or structure upon which the later builders expanded. The idea grows stranger when you recall the materials. The pyramid's interior granite, rich in quartz, behaves like a resonant crystal. When subjected to sound or pressure, quartz produces an electrical response. Piezoelectricity. Combine millions of tons of it in geometric harmony and you have something that behaves less like a tomb and more like a massive energy transducer, converting sound and vibration into subtle electrical charge. Could this be why the interior shows no soot? Why no lamps were needed? Some have theorized that the resonance itself produced luminous phenomena, faint plasma discharges, or piezoelectric glow illuminating the chambers with natural light. We may never prove this conclusively, but it suggests that the pyramid's emptiness is not neglect, it's design. The absence of ornament was not a lack of faith, but the opposite, a belief that divinity could be expressed in precision alone. To those who built it, symmetry was sacred scripture. But this perspective raises an even larger paradox. If the Great Pyramid was not a tomb, then what was its purpose? And if it wasn't Khufu's engineers who tuned this instrument of stone to the heartbeat of the earth, then who were they? By the 21st century, technology had advanced enough to probe these hidden questions. Muon detectors, ground radar, and satellite imaging began to peel back the layers of limestone, revealing corridors, voids, and subterranean networks never before seen. Each discovery seemed to whisper the same message. The pyramid is far more than we thought. In the next part, we descend once more beyond the known chambers into the hidden tunnels and sealed voids that modern science has only begun to uncover. Because if the Great Pyramid truly predates Egypt, then somewhere deep inside it may still hold the proof. Not of who lies buried, but of who once lived and built before history began. Beneath the sand, beneath the tourist trails and the chatter of cameras, lies another Egypt, one the public never sees. Down there, in the dark underbelly of the Giza Plateau, stone gives way to silence. The wind dies, light fades, and the weight of history presses down like the very rock that hides it. For centuries, explorers believed the Great Pyramid stood alone, isolated and self-contained. But modern technology has begun to reveal something astonishing. The pyramid is only the surface of a much larger mystery, an ancient network buried deep beneath the ground. It began, as so many revelations do, not with a shovel, but with a particle. In 2015, a group of scientists from Cairo University and Nagoya University in Japan launched the Scan Pyramids project, an ambitious attempt to peer inside Egypt's monuments using muon tomography, a form of cosmic ray imaging. Unlike radar or ultrasound, muon scans detect subatomic particles that constantly rain down from space, passing through rock and registering subtle density differences. It's the same technique physicists use to examine the interior of volcanoes and nuclear reactors. For nearly 2 years, detectors placed in the pyramid's chambers and around its base silently collected data. When the results were finally processed, they revealed something no one expected. A massive hidden void above the Grand Gallery. It wasn't a crack or a cavity. It was a deliberate structure at least 30 m long, centered within the pyramid's core. The data were clear. This wasn't a floor in the stone, but a chamber, a space deliberately carved and sealed thousands of years ago. When the findings were published in Nature in 2017, the Egyptological world erupted. Was this the lost burial chamber of Khufu, a construction gap, or something far older? The team called it the Big Void, careful not to speculate, but others were less cautious. Some noted that the chamber's position mirrors the Grand Gallery below, as if forming a symmetrical jewel, perhaps an architectural resonance chamber. Others pointed to legends of hidden archives buried within the Great Pyramid. Records from a forgotten epoch. Egypt's Ministry of Antiquities responded with silence, then restriction. Requests for drilling or further exploration were denied. The official explanation to preserve the structure. The unofficial one to preserve the narrative. Since then, new data have only deepened the mystery. In 2023, an updated MUN scan revealed a narrow corridor roughly 9 meters long, concealed behind the northern face of the pyramid above the original entrance. 3D modeling showed that it leads to an enclosed cavity, potentially intersecting with other larger voids deeper inside. Endoscopic cameras inserted through microbore holes captured images of smooth limestone walls untouched by human hands for thousands of years. There were no inscriptions, no tools, no evidence of plunder, just an emptiness, pristine and deliberate. Simultaneously, ground-penetrating radar surveys around the base of the pyramid detected a series of linear anomalies, patterns inconsistent with natural geology. These weren't random fractures, but structured voids forming grid-like corridors stretching beneath the plateau. Further afield between the pyramid and the Sphinx, researchers mapped irregular low-density zones extending downward more than 40 m. Some form perfect right angles. Others connect to known tomb shafts but continue far beyond their documented limits. Could these be natural fissures? Possibly. But beneath Giza, natural rarely applies. History itself hints that these discoveries aren't new. The Greek historian Herodotus, visiting Egypt in the 5th century BC, wrote of underground passages and a subterranean lake beneath the pyramid where the body of Khufu supposedly rested on an island. For centuries, scholars dismissed this as myth. Yet, modern surveys have confirmed the presence of large cavities filled with moisture, ancient groundwater sealed in stone for millennia directly beneath the pyramid's foundation. In 1837, Colonel Howard Weiss, the same man who found Khufu's Car-2, blasted into a deep pit below the Great Pyramid's descending corridor. He discovered a rough chamber he called the subterranean room. Carved directly into the bedrock, it resembles a half-finished tomb, but one with no sign of burial, no sarcophagus, no inscriptions. Some engineers now believe it predates the pyramid itself, possibly the remnant of an earlier structure or a core excavation reused by later builders. French archaeologist Auguste Marat, exploring the area in the 1850s, described tunnels as endless as they are ancient, leading away from the Sphinx toward the Nile. In the 20th century, British explorer Howard Vyse's notes mentioned unexplained air flow near sealed doorways, suggesting interconnected chambers below. These clues persisted but were ignored, overshadowed by the grandeur above ground. Modern geology adds another layer to the puzzle. Core samples taken from around Giza reveal thick deposits of Nile silt between bedrock layers, suggesting that the plateau experienced massive flooding long before the dynastic era. The last time the Nile reached that height was during the Younger Dryas around 11,000 tons 12,000 years ago. The same epoch linked to global cataclysmic floods. If structures existed beneath the surface, then they could have been buried, preserved under sediment, and later rediscovered by Egypt's early dynasties. This isn't speculation alone. In 1992, seismic studies conducted by geophysicist Thomas Becky and archaeologist John Anthony West near the Sphinx revealed cavities beneath its left pore, rectangular, symmetrical, and unmistakably artificial. Egyptian officials quickly sealed off further exploration. When reporters pressed for comment, the response was curt. No further investigation planned. To this day, those voids remain unexamined. So, what are these hidden networks beneath Giza? Storage chambers, construction ramps, or something older, something that predates even earliest kings? Some researchers believe the underground passages once formed a ceremonial complex where priests reenacted the pharaoh's journey through the underworld. Others more daringly suggest they are remnants of a pre-dynastic knowledge archive, the fabled Hall of Records described by both ancient Egyptian legends and later mystics like Edgar Cayce. Cayce's claim, dismissed by academia, described a hidden library buried between the pores of the Sphinx containing records from Atlantis, preserved against a global flood. While this story remains unproven, it's worth noting that radar imaging has indeed confirmed a large cavity beneath that very spot, sealed and untouched. Whether or not it holds Atlantean records, something is undeniably there. And perhaps that's the larger point. Every new scan, every new survey keeps confirming the same thing. The Giza Plateau is hollow, threaded with passageways and voids that defy our assumption of a simple pyramid on bedrock construction. The ancient builders didn't just raise monuments, they built into the earth itself. If the Great Pyramid is the tip of a buried iceberg, then its true story lies below. The corridors beneath may be older than the pyramid stones, dating back to a civilization erased by flood or time. Perhaps the pharaohs of Egypt found these ancient catacombs already in place and built above them, claiming their legacy as their own. Imagine for a moment under every step you take on the plateau, tunnels stretch into darkness, their walls carved with forgotten symbols, their chambers sealed since the dawn of history. They wait, perfectly preserved like the hard drives of an ancient world. And maybe, just maybe, somewhere in that darkness lies the final piece of the puzzle. Proof that the Great Pyramid was not the work of the Egyptians alone, but a gift or inheritance from a civilization far older than we've ever dared to imagine. In the next and final part, we'll follow that thread to its ultimate conclusion. The echoes of an age that may have ended in cataclysm 12,000 years ago, and the possibility that the Great Pyramid was built not as a tomb, but as a message, a monument of survival from before time began. Dawn over Giza. The first light touches the tip of the Great Pyramid, turning the limestone gold. The city beyond still sleeps, unaware that beneath this calm horizon lies the weight of a forgotten world. For thousands of years, the monument has stood as if waiting for the right tools, the right minds, the right moment to speak again. By now, we've seen the fractures in the official story. The painted name of Khufu suspect. The dating methods flawed. The engineering impossible for the Bronze Age. The precision beyond reason, the mathematics cosmic, the sky alignments prehistoric, and the tunnels below stretching into forbidden depths. All of them whisper the same question. What civilization built this? And what catastrophe erased it? Ancient myths scattered across the planet seem to remember fragments of one great undoing. A cataclysm that drowned the world and buried its memory in mud and ice. Plato wrote of Atlantis, an island empire destroyed in a single day and night of misfortune around 11,600 years ago. The same epic geologists now associate with the Younger Dust when a sudden global melt flooded continents and reset climate and civilization alike. Egyptian priests told Plato that their ancestors had only inherited fragments of a far older world, a world destroyed by fire and flood. They called its survivors the Shemuhor, the followers of Horus, the semi-divine beings who ruled before the first dynasties. Their memory was mythologized as gods walking among men, teaching writing, architecture, and the ordering of the heavens. To the Egyptians, the Great Pyramid and the Sphinx were not beginnings. They were reminders. If that sounds like legend, the Earth itself seems to agree. Around 12,800 years ago, the Greenland ice cores record a massive spike in platinum, a chemical signature of a cosmic impact. Nanodiamonds, glass spherules, and melt layers appear in strata from North America to the Middle East. Evidence of a global catastrophe. Sea levels rose more than 120 m in a geological blink. Entire coastlines vanished. What would survive such a reset? Not cities, not libraries, but perhaps stone. If a civilization existed before that event, call it Atlantis or something nameless, then its survivors would have migrated to regions spared from the worst floods, uplands, river deltas, the fertile plains of the Nile. There they might have preserved fragments of lost knowledge, astronomy, geometry, resonance, and rebuilt what they could, encoding their science in monuments too durable to erase. The Great Pyramid in that view isn't a tomb or even a temple. It's a message across epochs, a monument built not to glorify a king, but to preserve the memory of a civilization erased by time. The numbers begin to align. The date of the Orion correlation, 10,500 BC. The end of the Younger Dryas, 9,600 BC. The emergence of advanced sites like Göbekli in Anatolia suddenly appearing with megalithic architecture and celestial alignments. These are not isolated sparks of genius, but embers of a forgotten fire. The same blueprint rising again in scattered hands. Perhaps the builders of the Great Pyramid were the inheritors of that fire. Refugees of a cataclysm who encoded their world's knowledge in indestructible form. The limestone shells symbolize the earth. The granite core energy, the ascending shafts, the path of the soul, geometry as language, proportion as memory. Everything they knew, mathematics, astronomy, time folded into one timeless structure. And maybe they knew it would not be understood. Maybe that was the point. The pyramid wasn't built for the people of its own time. It was built for whoever would rediscover it after the next cycle of destruction. A cosmic archive, a seed for civilization's rebirth. The idea of cycles runs through every ancient culture. The Hindus speak of yugas repeating ages of rise and fall. The Mayans described 5 suns, each world destroyed and remade. The Egyptians themselves believed in a recurring flood of none. the primordial waters that reset creation. Even modern science now recognizes Earth's pattern of cataclysms every 12,000 years. Sudden shifts in climate, magnetic reversals, impact winters. If the Great Pyramid dates to the last such turning around 12,000 years ago, then its builders may have known what we are only rediscovering, that civilization is not a straight line, but a circle. We rise, we fall, we forget, and we begin again. Maybe that's why the pyramid endures, not as proof of one lost civilization, but as the heartbeat of many, a pulse of memory across ages. Its silence is deliberate. Its perfection is a language we have only begun to read. And what of the voids discovered inside the tunnels below? Perhaps they hold more than air and sand. Perhaps they hold a record waiting to awaken, not in words, but in resonance, a frequency that one day, when rediscovered, will vibrate again and speak the story of the first time. For now, the monument waits. Each dawn, sunlight climbs its face exactly as it has for millennia, tracing the same lines, igniting the same stone. The earth turns, the stars shift, the ages pass, but the pyramid does not move. It is the needle that stays still while time spins around it. Maybe that's the final secret, that the Great Pyramid was built long before the Egyptians, not as a relic of death, but as a mirror for the living, to remind whoever comes next that we have been here before. And as night falls again, its shadow stretches toward the stars it once mirrored. Silent, eternal, watching, waiting for us to remember. Where are you listening from tonight? And at what time does your sky align with theirs?